In the previous example, we have seen that the Turing machine works as an adder. Okay, it is an example of language generator where we can write in a tape, and obviously since it's an adder, you can say it is a transducer because we use the mathematical function. Now in this example, what we will do, we will design that a Turing machine that replaces all occurrences of 111 with 101. That is, the middle one will be replaced by 0. Okay, so our problem is design a Turing machine that replaces all occurrence of 111 by 101 from a sequence of zeros and ones. Okay, so let us take a first tape. Let us say I take a tape like this format. Say this is a tape, so one, let us take like this way, 1 1 0, then 1 1 1, okay, then again 0, then 1, then blank blank, here also blank blank. So let us take like this a tape. Okay, so this is a tape. So what will be answer? 1 1. So this 111, this will be replaced by 0, it will be replaced by 0. Okay, and like this likewise. Okay, so to do that, let us take one from the initial state. Start with the initial state. Let us say suppose q0. Yeah, q0. So what you have to do, you have to read all the ones. If suppose that is all 3 ones, consecutive ones, so you have to read it. So first one you read, replace that 1 by 1, moves towards the right, you go to the q1 state. Again if you read with 1, replace that 1 by 1 and moves towards right, go to the q2 state. Okay, again if you read third one, replace that 1 by 1 and moves towards left. Okay, moves towards left. See, it is from q0, you read this 1, you replace this 1 by 1 and moves towards right, and you are in q1 state. You are in q1 state, you read this 1, replace this 1 by 1, moves towards right and go to the q2 state. Again you read this 1, replace this 1 by 1, but what you will do, you will not move right, you will move left to replace this 1 by 0. So that is our main intention. Okay, so while moving towards left, you go to the q3 state, right, and in the q3 state you will do what? You will replace this 1 by 0. So you will read 1, replace this 1 by 0, and what you will do, you will move again right. Okay, and go to the another state, that is q4 state. Okay, so you are now in the q4 state. So from the q4 state, if you read another 1, okay, if you read another 1, so if you read another 1, suppose the sequence is like this way, 1 1 1, and again it is suppose 1. Okay, so what you will do, what is happening over here? See, you read this, you read this, you read this, then you move towards moves towards this q3, replace this by 0. Okay, and moves towards right. So you are now reading this, and after that you go to the again q1 state. So I represent this way. This means what? This is nothing but you are reading this 1 by 1 and you are ready for moving to the right. Okay, Okay, now this is sequence. Now see, suppose there are many things which may happen, that suppose the string is like this way. Initially the string is like this way. Okay, or initially string may be like this way. Then what will happen? That is starting with 0. So in those cases, see, if you read 0, what you have to do? You read 0, replace 0 by 0 and moves towards right till the first one is not encountered. Okay. Now this is one situation. Another situation can happen that after q1 it may be 0. That is, initially the string is like this. That is, from in q0 you read this, replace this one by one, move to q2, but q2 is not now reading 0. So in this case, that case is encountered by this way. You read 0, q1 will read 0, replace this 0 by 0 and moves towards right. q1 will read 0, replace this 0 by 0 and moves towards right, but it will change state to q0. Okay. Now why I am taking q0 again? Because again from here you have to count another consecutive 3 ones. So again means that you are basically starting from initial level. So this one. So same thing can happen from here also. That is, in this situation you read q0 reading this, then replace one by one and go to the q1 read this, replace one by one, go to the q2 now reading this. So what will do? It will read this, replace 0 by 0 and it will do what? It will again move towards right and it will start from q0. So this is done by like this way. Okay. So q2 0 replaced by 0 and moves towards right. Okay, now this one. Okay, now another thing you can say that for any other combination, what we can do. Suppose now you have exhaust all the things. Okay, so suppose my string is like this way. There is blank, so you have replaced this by this. Okay, then again you have one q0. Now your q0 is reading blank. So since q0 is reading blank, that is basically you have replaced 1 by 101, then you will be in the I think this. Okay, replace blank by blank and moves towards left. Okay, and you are in the q5 state. So basically when things is exhaust, you are reading then this blank, replace this blank by blank and moves towards right. This is right. Okay, and go to the q5 state. Same thing can be happen from q1. You can go to reading blank by blank and moves towards right, and same thing can happen from q2 also. Blank by blank and moves towards right. Okay, so this is the Turing machine that replaces all occurrence of 1 by 1 with 101. So let us again recapitulate what we have done. So starting from q0, if you read 1, replace 1 by 1, moves towards right. Again 1, replace 1 by 1, moves towards right. Go to q2, then read 1, replace 1 by 1, but in that case you will move towards left to replace this middle 1 by 0. So and after that you are reading in the q4 state, and q4 state will read 1, replace 1 by 1, moves towards right, and again it will go to the q0 state. Okay, and this is the normal condition, and if in middle 0 may appear, so you will replace 0 by 0. Initially 0 may appear, so you can replace 0 with 0 until and moves towards right till you don't encounter with the first one. So these three things are happening, and this is the final if you reach to the final state. Okay, so ultimately if the thing is exhaust, then it will go to the final state. Okay, so same thing can be happened. So this is the example of one Turing machine. And in the next example, we will design a Turing machine that accept well-formed parenthesis. Basically, well-formed parenthesis is can be accepted using PDA, that is push down automata. But here we will see that how a Turing machine can accept a well-formed parenthesis. Now, since the push down automata can accept, Turing machine obviously will accept. But still, we will see this example that how a Turing machine accepts a well-formed parenthesis. Okay, thank you.